It's almost time already, so we'll go ahead and get started. Okay. All right, so what I'll do is I'm just going to open up the activity. I'm not going to answer those questions for you, but I will explain the concepts. So you go to this activity, the passcode once again is Johnny, Johnnny, all lowercase. And then once you get into it, just give me a chance to explain the concepts. Okay. So the first question, quote unquote question, these are all instructions. The first thing you need to do is to go to the hyperlink of this folder. That will bring you to the shared folder for the processor stuff. And in there, okay, let me change the listing of the files. So in there you will find the files that you need to download. One is alu.circ, so this is one file. One is called regbank. Okay, let me get rid of this. And you can do a control click to select multiple files at the same time so that you don't have to like download one file and then download the next one and then download the last one. So you can do a control click to select all three files, and then you right click and specify download. So what that will do is Google will compress all three files into a zip file, and after you download the zip file, you can unzip it back into the three files. Okay? Or if you prefer to download these files individually, you can do that individually. Okay? So that's what that step is for. So, but don't do the steps just yet, because I'm just trying to explain the concepts behind the whole thing. And then I want you to start up Logisim, and in Logisim, even though you have three files, you only want to open processor WDPC2 because that's the main file that you need to open. Okay? Now when you try to do that, it will give you an error, and it will say blah 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 blah. And when that happens, you need to navigate to where those missing files are located and double click on the file so they can tell Logisim where those files are located. Okay? You will see it when you run it. Okay? So that's just procedural. That's just the steps that you need to do. Now, question number 3 is starting to be kind of more important because it is it's related to how you write code with this processor. There are two documents involved. One is the opcode table. The other one is the assembler manual. The opcode table looks like this. Okay, now you can make a copy of all the documents that you have a link to so that you can annotate your own copy. Okay, if you do not make a copy, this is my copy and you cannot overwrite the content of my copy. But if you want to download one, that's fine. Okay, everything is quote unquote open sourced. Okay, this is from the earlier download thing. It's just a zip file that it wants to download. I'll save it. So the question is asking about a particular instruction. So if I switch back to the question, based on these two documents, what is the opcode in base 2 to subtract register B from register D? So what you need to do is to read the documents. You have to read this one and also this one to find out what is the opcode of subtraction. And in the opcode of subtraction, how do you specify you're subtracting which register from which other register? Okay? Now, I'm just going to give you an example. So instead of using subtraction, I'm just going to use addition. Okay? So let's say we are asking about addition instead of subtraction. So you basically look up the table and go like, okay, what instructions are responsible for addition? This one is responsible for addition. And in the middle column, in column C, it shows you the effect of the instruction. So when it shows you that, what's the access code again? Johnny, Johnnny, Johnny, all lowercase. Okay, so when you look at add, okay, this is the add instruction. It shows you that there are two operands. Okay, so you have to specify something in the place of x, something in the place of y. Whatever you specify in place of x is also going to store the result of the addition. Whatever you specify in the place of y is only specifying how much to add to what you specify in place of x. Okay? So what are these x and y's? The next document will tell you about those things. So you can switch all the way to syntax, and it shows you. So x has to be a register, y has to be a register. We have 4 registers, A, B, C, D. So those specify registers. X is a placeholder for one register. Y is a placeholder for possibly a different register. Is that okay? Sort of? Okay. I mean, you guys can retry it a few times. I think this is taking the highest possible score, so you can actually do it, many times over if you want to. Okay, so getting back to the question. So the question is asking what is the actual opcode. So what you need to do is to kind of make sense of the spreadsheet. So if I'm working with the add instruction, this is the opcode of the add instruction. It's 1000, and then it has got XXYY. XX specifies the register in place of X, YY specifies the register in place of Y. Okay, why do you think there are 2 bits to specify X and there are 2 bits to specify Y? We have 4 registers, so how many bits do you need to specify 4 different bit patterns? Okay, so we got 4 different things to specify, right? So 00 can specify the first, 01 specifies the next, 10 specifies the next, 11 specifies the last. So that's why you need 2 bits to specify one of 4 different things. And that is why we have XX as a bit pattern to specify the register that you want to use in place of X, and then we have YY to specify the register to be used in place of Y. Okay? Yep. It would be the destination. I wouldn't call that an address, but it will be the destination of the register. Is that okay? So register A is 00, register B is 01, register C is 10, and then register D is 11. Are we okay with that? So what is left for you to do is to find out what is the binary code of the subtract instruction and what to use for in place of XX and YY. The question itself specifies which 2 register I want you to use. So in the instruction here, I want to subtract register B from register D. So now you have to specify, you have to understand which one should be used in place of X and which one should be used in place of Y. That has to do with the documentation of the subtract instruction. So you have to read that in documentation first. All right. As you can imagine, writing the whole program in binary opcode by hand can be quite cumbersome because you will just be specifying a whole bunch of zeros and ones. So what we need to do is to use an assembler. So there's another hyperlink here. If you follow that hyperlink, it will get you to the assembler. So this is the assembler. Don't be tricked by the appearance as a spreadsheet. It really is an assembler. I wrote an assembler out of a spreadsheet. Okay, so this is your assembler. And then the instruction says you will need to make a copy of this into your own Google Drive, okay, just like with your previous 2 homework assignment with the positive exponent and the negative exponent. You have to make a copy of your own spreadsheet. Do the same thing here, okay? Do the same thing. And then try out the assembler. Type what without the quotes in cell A1 of the source sheet, okay? So when you go to the spreadsheet, there are many tabs down below. Okay, some of you may or may not be able to see it. The first one is README, the second one is source, and then we have source debug. mnemonics, assemble, and output. Most of these are locked except for source. Okay, so you want to click on source and follow the instruction and type in what? WHAT. Okay, and then the question is asking you about what error message are you getting back. Okay, so you just have to do it and find out which one matches the error message. Question number 5. Question number 5 says, look, now don't worry if you don't understand what this program is going to do. You're not expected to understand this entire program. So all you have to do is to copy and paste this into the spreadsheet. When I say copy and paste, I literally mean just copy and paste. So you just copy, Control C, go to the assembler spreadsheet, go to the source tab. Remember to do it in the source tab and in column A. Do not do it to anywhere else of the spreadsheet. And then you just paste it in. Okay, I'm not going to paste it because if I paste it in my master copy, then I have just done the homework assignment for all of you. So I'm not going to do that. So just do a Control V over here and paste it. Okay, so after you paste it, okay, so the detail of the assembler can be viewed in the assemble mode. So that's completely optional. And I want you to find out what is the content at location 08. So if you want to find out what is the content at location 08, there are several ways to do it. So you can look at the assemble window. You can also look at the output window. In the output window, the first column has a header of what? Address. So what you're reading here is address 00, address 01, address 03, and so on. So if this is the program that you're dealing with, then 08 on row 12, FE is the content at that location. Okay? But remember, this is from a different program, so it is unlikely that FE is also the content of the location of your program. So don't copy this. I'm just showing you how to read this particular tab, which is called the output tab. Okay, so use the output tab to understand what is the content of a particular location. What about 02? I don't see 02 of the address column. So what is the content at location 02? What do you think? Well, we went from location 00 has a content of 9F, location 01 has a content of 6C, location 03 has a content of 9C. Oh, but where's location 02? Where do you think it is? Okay, first of all, why do you think it skipped from 01 to 03? Because there are two things on the row that starts with 01, right? So the first thing that starts on the row with 01 is the content of location 01. What do you think the 33 is corresponding to? The content of address 02. Okay? So is that okay?
Why is it that way?
Because some instructions require 2 bytes. Most instructions only require 1 byte, but some instructions require 2 bytes. Okay? So that's how you answer that particular question. Question number 6. Actually, I actually include instructions here of what to look at to find out the actual values. In question number 6, get the assembled result into the RAM component. Okay, so the way to do it, the instructions are here already, but I will I'll show it to you by doing it. So you go back to the assembler spreadsheet, but this time you go to RAM file. Okay, so you go to RAM file. The first thing you need to do is to make sure that the first row says v2.0 raw, because if it's not, that means there's a problem with the assembly process. So you have something else to fix in that case. If you see this, that means it's ready. So the way you download this is to go to File, and then click Download As, and then you just click comma separated value or tab separated value. Both will work. Okay, you can pick one or the other. Doesn't really matter which one. So once you pick it, you just give it a name. The default name is not going to be very sensible, so you just give it a name, and you can say RAM content if you want to. So RAM content. The extension, you can keep it the same, doesn't really matter. And remember where you put it. In other words, when you download it, by default it is downloaded to the download folder, but if you specify other locations, you just have to remember where you put it. I put it into the temp folder. Click save. Now we switch back to LogiSim. So when we switch back to LogiSim, yours is not going to look like this because this is just from the class. Yours is going to look like this. So you go to the RAM component. Now remember to differentiate between RAM and ROM. Okay, this is the RAM, the other one is ROM, because we have a ROM module as well in this particular design. Right click, load image, and then you go to the folder where you save the file. So mine was saved to the temp folder. It has the name of, I think it's called RAM content.tsv. Open that file. So now the content is fully loaded into the RAM. Okay? So after that, let's see what we do. So all of these are basically instructions to do exactly the same thing, except I just did it in the example so that you can see it. So the next thing we want to do is to run it. To run it, you can type Control K to enable clicking, to enable the clock. And the default frequency is pretty high, and your program should finish pretty quickly. So let me switch back to LogiSim to show you what I mean by that. So when you go to simulate, you can do everything by hand too. The default tick frequency should be 4.1 kilohertz. Mine is set to 0.025 hertz because of teaching in the class. So yours should probably be all the way up there at 4.1 kilohertz, which is really fast. So when you type Control K on the keyboard, you'll see a whole bunch of stuff happening, and then it will stop. Okay, so now there's no activity doing anything. You type Control K again to stop the whole thing, and then you go back here. So this particular question is asking you about the content of a particular register, and that particular register is the program counter. So you have to find the program counter in the processor. Okay, let me switch back to the processor. Where do you think the program counter is? There you go. Yep, you're staring at it. Okay, so if you cannot find it, just be patient and just look through the whole thing and find the program counter. It has a particular content. So you have to report back that content in the register. Huh? Huh?
I can't find it.
Well, I mean, okay. Since you asked that question, if you zoom out, that's not so obvious anymore. It's only obvious because I knew where it was and I navigated when it's already zoomed in, and that's why you saw that PC to be pretty obvious. But if you're new to this and you have a high resolution screen and the whole thing looks like this, it's not that obvious anymore. It's almost like where in the world is Waldo? Yep. Okay. So the last question is, it's time to stop clicking. After you stop clicking, I want to know what is the value of register C. Where's register C? Register C is nowhere to be found here because it is inside the register bank. The register bank is this thing here. Okay, let me zoom back in again. So this is the register bank right here. And then what you need to do is to right click on the register bank. Do not double click it, okay? Double clicking it is not the same as view register bank. So in here, you will find register A, B, and C. Register C is the one that I'm interested in. So whatever number you see here in hexadecimal is the answer that you should put into Canvas. Is that okay? I think this gives you a head start in terms of, what to do with all this stuff here. It's going to take you a little bit of time, and that's why this is due as long as it is today, Pacific time. Because I don't want someone to complain, but what about Hawaiian time? All All right, so you guys go ahead. I'm going to stop the recording. This was all recorded because I used OBS.